but it's adding to it, right? Adding to it, all the red arrows are energy. It's adding to it what's happening to the nutrients or the molecules or the chemicals, right? So there's two different things that are moving through the ecosystem, energy and matter, right? So matter is going to be anything that has volume and takes up space. So basically anything that's made of atoms and molecules, right? Energy is this, sort of philosophical thing that doesn't have mass or take up space, right? So all of the energy that's coming in to our ecosystem is going to come from the sun, right? So the sun, this is an external resource. Basically, we think of the Earth, the biosphere, as a relatively closed system, right? Most of, in terms of matter, right? We don't have very much. There's a little bit. Don't worry about that little bit. There's a little bit that might be flying off into space, the odd, ozone molecule that we lose from the upper atmosphere. And there's the occasional asteroid that comes in, right? But the vast, vast, vast majority of all the molecules that we have on Earth are here, have been here, are going to be here, right? So closed system from the perspective of matter, but an open system from the perspective of energy, right? The energy is coming in from the sun, and actually some of it is leaving as heat as well, right? So we're going to have something happening with energy, right? It's going to get passed from the bodies of producers to consumers, secondary to tertiary consumers, et cetera, et cetera. Notice that at every step, some of it's being lost as heat. Even plants are losing a little bit of energy as heat. They have to take those glucose molecules and turn them into ATPs. That process always loses a little heat. In fact, if you have a very sensitive infrared device, you can see that plants are a little bit warmer than the environment around them, right? So there's always, this is one of our laws of thermodynamics, that no chemical energy transformation is 100% efficient, that we're always going to be losing some, right? So we're losing energy as heat. All right, what's going on with these other groups on here that we haven't seen before? So we have these secondary consumers, primary producers, tertiary consumers. All of these are kinds of plants and animals. And what's going to happen to them is that they're going to die, or parts of them are going to fall off, and they're going to produce waste products. So if you imagine a forest or a chaparral region, there's leaves that are going to drop off. Sometimes a branch gets broken off of a tree. Animals are going to be coming through. They're going to be pooping and peeing. You might have some fur that comes off. They're going to leave bits of their food. A mouse is going to eat the seeds and leave some of the husks laying around. A coyote is going to eat a rabbit, but it's going to leave the fur and the bones. And so those will be laying, or little tidbits of its mass are going to be left over. Right, so all that stuff that's laying around, it's kind of fallen onto the ground, that's dead or decaying, is going to be considered this word detritus. Right, detritus is sort of leftover trash that's fallen. If you've got a bunch of food wrappers and empty water bottles on the floor of your car, that's detritus. This is stuff that's fallen and it's left over and it's piling up there. All right. Now, some of this matter is going to continue to be broken down, and the remaining energy that's used in it is going to be used by detritivores. So we have herbivores eat plants, detritivores eat detritus. And bacteria and fungi are major components of that part of the ecosystem. So things that live in soil, worms, insects, roly-polies, anything that's going to be eating that broken down, decaying organic matter, right? So those tidbits are going to get broken down into even smaller tidbits. And basically, this process is going to end up remineralizing or recycling all of the atoms and molecules that were left over in the body parts of those plants and animals and in their fecal matter and other waste products, it's going to go back into the soil. So when we're talking about a terrestrial ecosystem, everything goes into the soil. Remember, the plants are getting the nutrients out of the soil. In a marine ecosystem, basically all this stuff falls down to the bottom, right? And it lays there in the sediment. Okay, so same thing is happening in the marine ecosystem, that we tend to talk about it as being in the sediment, not in the soil. And then we have to get the sediment mixed up with water flow in order to return those nutrients to the shallow water where the sunlight is, so that the single-celled phytoplankton can absorb those nutrients and be able to do photosynthesis. Right. So we have kind of this very complicated looking diagram, but I'm going to redraw it for you briefly. And one thing that bothers me about this diagram is that it has this big blue arrow going around the whole outside. And that's a little confusing. I don't understand what they mean by that. So one thing about these diagrams in the textbook is sometimes they're real nice, sometimes they're a little confusing. So I'm going to stop my share and I'm going to redraw this diagram for you to help you kind of clarify what are the things that are important and things that are not important, right? But basically, the take-home message is that nutrients, atoms and molecules, are temporarily stored in the bodies of living things. They get recycled into the soil by the processes of death and decomposition, right? And then they go back into the primary producers from where they are passed on, right? So any nutrient molecule, say iron, that's absorbed by a primary producer and stored in its body, when a primary consumer eats it, that's how it's getting its iron, right? So for any molecule or atom of interest, we're going to see that it is recycled. Okay, so matter gets recycled. Energy is coming from outside the ecosystem. It's coming from the sun. It's temporarily used and stored in the bodies of our plants and animals and other living things, but it's always eventually lost as heat, and we have to keep getting more. Okay, all right, so slightly different version of this diagram for you. Share my screen.